Hi, welcome to my class. This is still Maths with Victor, and we are still on our series on circle theorem, and this is lesson 7. So we have a question. A chord is 4 cm away from the center of a circle of radius 5 cm. Find the length of the chord. So before you answer this question, it's very important that you illustrate it in a diagram so you see what you have and what you're looking for, and the theorem that will connect the known to the unknown. So we illustrate a chord is 4 cm away from the center. So we draw a chord. We know how a chord looks like, right? So I have a chord here. It can be anywhere. A straight line from one end of the circumference to another end of the circumference. So we have a chord. Let me label it AC, chord AC. And then we are told from the question that this chord is 4 cm away from the center, which means the distance from the center of the circle to the chord is 4 cm, which means this is my center of the circle. From the center of the circle to the chord is 4 cm. That's the implication. The chord is 4 cm from the center. All right? Then we're also told that the radius of this circle is 5 cm. What is a radius of a circle? We discussed that in our parts of a circle. The radius of a circle is a line, a straight line, from the center of the circle to any point on the circumference. So this is not a radius because it didn't get to circumference. So we draw a radius. I will join a straight line from the center to this circumference at this point so that I will have a triangle. I can also extend it this way so that I will have a triangle if I want. But this should be enough. So let me call the center of the circle 0. So this radius is 5 cm, a line from the center to the circumference. This is also a radius from the center to the circumference, which is also 5 cm. Let me label here B as the case may be. So we have a perfect diagram, so we can proceed with the question. So what do? We are looking for the length of the chord A to C. But notice something. There is a line from the center of the circle to the chord. And we discussed it in our previous lesson that line must do two things. Number one, it must be perpendicular. It must be perpendicular, which means it must form an angle of 90 degrees here. And then number two, it must divide this chord into 2 equal parts, which means from A to B is the same as from B to C. So a perpendicular bisector of a chord must pass through the center of the circle. So we've done that and we've been able to achieve that. So look at this triangle BOC. Can I bring it out? Triangle BOC. Here is O. That's my B. This is my B. This is my C. And then this is a right angle, which means that this triangle is a right angle triangle. This is my 5 cm. This is my 4 cm. Can I get this? Yes, I can. So whenever you have a right angle triangle and two sides are given and one side is not given, you can remember your Pythagoras theorem. What is Pythagoras theorem? The hypotenuse square is equal to opposite square plus the adjacent square. So we can apply that theorem here. My hypotenuse is the longest side, which is 5. 5 squared is equal to, either of them can be opposite or adjacent, as the case may be. 5 squared is equal to s squared plus 4 squared. Simple equation. 25 s squared plus 16. When you square the numbers, collect the like term, this moves over. 25 minus 16 equal to s squared, which means that s squared is equal to 25 minus 16 is 9. So to get x, square root of 9, therefore x is equal to 3 cm. So our x is 3 cm, but remember our x is B to C, which means B to C is 3 cm. Look at the question again. Find the length of the chord. B to C is not the chord. The chord is A to C, right? But if B to C is 3 cm, A to B must be 3 cm too. Why? This line from the center to the chord must divide the chord into 2 equal parts. So this is 3, this is 3. Therefore, length of chord is 6 cm. So our final answer is 6. 3, 3 gives you 6. If you're just joining for the first time, kindly invite your friends, like, share my videos, and subscribe to my YouTube channel. Thank you, and watch out for the subsequent video on circle theorems. Bye.